We were solving these exponential and logarithmic equations, and we always managed to have the same base. And as long as the base was the same, everything was cool. But what about the dreaded case where it's not the same base, a different base? What are we going to do then? Da 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 da. A little ingenuity is necessary here. What we're going to do is first we're going to take the ln of each side. Now, we have the property of lns, which is that the exponent here can become a coefficient there. And now we are at a step where it's very simple. Now, you're saying, what do you mean simple? It looks very complicated. Well, it's not. I'll tell you why. Because ln 5 and ln 4, they're just numbers. They're just numbers which I could look up on a calculator. So they're just regular constants. Anyway, I'm going to distribute and solve for x. Again, ln 5 is just some number. Well, I'll tell you exactly what it is. Ln 5 is just 1.6094, and ln 4 is just 1.3862. They're just plain numbers. They're just numbers. But before I do any of that, let's regroup. I'm just bringing things over to the other side. So I'm putting all the x's on this side and all the numbers here. I'm going to factor out an x. I'm going to condense this. Why not? So x is equal to negative 2 ln 5 over the ln of 1.25. Where did I get 1.25? That's 5 over 4 written as a decimal. And I could easily figure this out. Again, this here is really the exact answer. It's in terms of logarithms. This here would be just, ln 5 is this, so ln 1.25 is that. I see those numbers right up here. I looked up. How did I get these numbers? I just looked them up on the calculator. But that gives us x is equal to approximately negative 14.4248. And that, my friend, is how we solve a equation when we don't have the same. That is how we solve an equation when we do not have the same base for our logarithm or the base for our exponent. We get creative. Yay!